Question 2, consider the functions f of x equals 12 raised to the x power and g of x equals negative 2 times 12 raised to the x power. Which transformation must be applied to function f to produce the graph of function g? So f of x equals 12 raised to the x. This is our parent function. This is the starting point or the before. And this is the transformed function. So we want to focus on this chart to the right. This gives us what essentially is a formula to follow to understand the transformation. So we can see first off there's a number in front of the parent. It's a negative 2. So let's go over here and look at the rules for A. First off, it says right off the bat, if A is negative, then there is a reflection over the x-axis. So we can go ahead and check this one here. Reflection over the x-axis. One place I quibble with this really should say if the absolute value of A is greater than 1. Because the A value really, if we think about it really carefully, it's negative 2. I think this problem is wanting you to say it is positive 2 and we're leaving the negative out of it. So the absolute value of negative 2 is greater than 1. So this is a vertical stretch as well. So the negative 2 reflects over the x-axis and it stretches it. It's only a vertical compression when the A value is a fraction between 0 and 1 or 0 and negative 1. And then finally we've got, no, that's it. There's no other numbers in this problem, so that's our answer. Reflection over the x-axis and vertical stretch. I strongly encourage on a post-test or an EOS test, plug this into your calculator. So let's get a graphing calculator out. You can find these online for free all over the place. Just search graphing calculator. We're going to type in the parent function, graph it, take a look at it. All right, now we're going to go down to y2 and we're going to type in the transform function, which is negative 2 parentheses 12 close parenthesis raised to the x power. And we're going to graph this and see how it's transformed. Usually the calculator trick works better if we're shifted left, right, up, down. So this will be a little bit tougher to see. But I think you can still see how it's been at least as far as the reflection goes. You can see pretty clearly there's a reflection. It's difficult to tell how much this graph has been stretched or compressed. So that's why the rules are handy to know as well. So use the graphing calculator to get a visual and use the rules to help you get this answer.